So we're going to do about 10 examples here, and I'm doing a lot of examples just because it takes a lot of practice to get comfortable with this. And our first one, I'm going to show you how a lot of these examples requires more than one transformation, and so that's what we're doing here. We have y equals minus the absolute value of x plus 1 plus 3. Now, we can see that this can, the basic function here that we start with is the absolute value function. And then it turns out we need exactly 3 transformations to get from the absolute value of x to here. So if we have y equals the absolute value of x, we can start with that. And then our first one, we can replace this x with x plus 1, since that's what we have here. And then we can multiply the whole thing by minus 1. And then finally we can add 3 to this. Okay. Now, what that does is that has the effect. Let's see what transformations this corresponds to. Here, this first one, we replace x with x plus 1. That's a shift left 1 unit. Then we put a minus sign out in front of the whole thing. So we're changing the sign of the y coordinate. So that's a reflection through the x-axis. And then we are going to, add 3 to the whole final thing. So that's going to be a shift up 3 units. Okay. So if we look and see what's going on, what the graph will look like. Okay, we start with the absolute value function, and then we shift it left 1 unit, and then we reflect it through the x-axis, and then we shift the whole thing up 3 units. So this was going to go up 3. Okay. Okay. And that, in fact, is going to be our final graph. Okay. And in fact, you can double check that when we go through it, the y-intercept is going to be at 2. Because if you plug in x equals 0, you get minus 1 plus 3, that's 2. So we get this graph. Okay. That's one way you can do a couple things. Basically, when you see a constant, a plus 3 or a minus 5 way out here, you want to do that last. You want to take care of that substitution last. So the order is important here. Normally what you want to do is start with your, if there's any changes that are to the x, you want to take care of that first. Basically, you want to work from the inside out. Then, address the change in x coordinates first, then do any reflections, and then finally do the y coordinates, so the shifts up or down. Now, for this next example, we can see that there's really just one transformation here. We start with the graph of y equals 1 over x, and then we replace x with x minus 2, so we're shifting it to the right 2 units. Okay. Now, we know what the graph of y equals 1 over x looks like. Okay, and we can see that we have this vertical asymptote at 0. Which is the y-axis. Now, the thing here is we need to, if we're going to do, we have to transform the asymptotes as well as the graph itself. So, I think you can probably see that this function, as a function, 1 over x minus 2, that's defined everywhere except 2. So we're going to have a vertical asymptote at 2. And in fact, that's what we have. Okay, we have we shift this to the right 2 units, and then we shift the pieces of the graphs to the right 2 units. Okay. All right. And so this is the graph. This is our final answer.